Hello again. So we're going to look at one more example involving the quadratic formula. We are still looking at this same example we've looked at a few times by now. This time we're asking when the object will reach 15 meters. Remember, this equation is the height of a thrown object. So to start with, this problem looks just like the problem in the last video. We have a quadratic. It's not being set to 0. We've got something else here. Subtract 15 from both sides. This is the exact same trick we used when we had a 12 in the last example. 7.5 minus 15 should be negative 7.5 equals 0. And now that we've got a quadratic equal to 0, we can use the quadratic formula which I'd meant to write down, but my hands started moving on their own, and before I knew it, I'd written down numbers rather than a formula. But you've seen the quadratic formula a few times by now. And once again, we want to enter this into our calculator. And once again, to make this simpler and minimize error, we're going to do this in a few steps. We'll simplify this, and we'll simplify the thing under the square root here. This is negative 9.8. The details of where this formula comes from is a calculus problem, but negative 9.8 is acceleration under the effect of Earth's gravity, so that might give you some idea. Let me see. New share. I want that calculator. B squared minus 4 times A times C, negative 47. So let's go back to my document camera. Here are the answers, and probably many of you can already see the problem we're rushing towards. But if you can, let's pretend for a moment that you can't. Just humor me. So we're going to enter this into our calculator. We'll need parentheses around the numerator. And that's -10 plus the square root of -47 divided by -9.8. And we get an error message. And non-real answer. Back to this. This square root, the square root of a negative number, is imaginary. So I've said that sometimes, imaginary and complex numbers just show up when things are rotating. They're not, they're not fake. They're not actually imaginary, but here, this answer is kind of fake. For the word problem we have attached to it, sort of like when we set this equal to 0, we got this second solution, and it was an actual solution, but also it doesn't mean anything in the context of the word problem. Likewise here, this is a solution. It doesn't mean anything in this context, though. And what's happening is that 15 meters is up here. So the object rises, it reaches its maximum height, less than 15 meters, and then it falls to the ground. So this solution is meaningless. We could simplify it if we wanted to. In fact, just as an exercise in algebra and simplifying stuff and working with complex numbers, if we've got addition in the numerator, we can break that addition up over to our calculator. We'll figure out what this is, and we'll figure out what this is. New share, here we are. -10 divided by -9.8. Let's keep 3 decimal places, kind of arbitrarily. 1.020. Then 1 divided by -9.8. minus 0.102 times the square root of negative 47. Let you see that. So that's this, 1.020 minus 0.102 times the imaginary unit times the square root of positive 47. So we can simplify this further. We can take this I over here and then multiply these together. Negative 0.102 times the square root of 47. Let me just jot this down as quick as I can so that you can then actually see what's going on. Here's our solution. And we had another solution, plus or minus. This comes from plus. Our other solution is also complex. It's a theorem that if you are solving a quadratic and you get a complex solution, the other solution is also complex and it's the conjugate of the first solution. So that's how I knew to just turn this subtraction into addition. I mean, the other alternative would have been to just simplify the second solution in this way.